and the project as a whole of trying to really rethink the relationship between philosophy and math. Now, he's a Platonist in a very specific sense. I'm going to read two of the great mathematical definitions of Platonism. One is by Putnam. In general, the Platonists will be those who consider mathematics as a discovery about truths which exist independently of the activity of mathematicians. In other words, there's a transcendent realm of beings which mathematicians access, but which is independent of them. And so, but for instance, if something is unprovable now, well, let's wait till the next generation of mathematicians. We have problems with finding the square roots of certain numbers, so we've invented imaginary numbers, and then we could solve those dilemmas in another domain. Another famous definition by Frankel and Barhilla, who give us some of the basic axioms of set theory. A Platonist is convinced that corresponding to each well-defined monadic condition, which is to say the attribution of a predicate to a variable in the form of Px, there exists in general a set or class which comprises all and only those entities that fulfill this condition, and which is an entity in its own right of an ontological status similar to that of its members. So in other words, that we're moving in this second definition to trying to say that a Platonist is somebody who believes that unsolvable problems can be broken down in their unsolvability, and that therefore there can be a way of comprehending what is unsolvable. Now you see, that's very different than undecidable. Comprehending what is unsolvable is very different than undecidable. You're saying that you know why this particular problem can't be solved. And in fact, what Paul Cullen did was do exactly that. Paul Cullen, in his famous proof, showed that Cantor's continuum hypothesis could not be provable within the conditional axiom of zero-Frankel set theory, and he showed why in his proof that the continuum hypothesis could not be provable. Now, why does, and Cullen was a kind of Platonist, why does he make the effort to show why it cannot be provable? Because if he can show why it cannot be provable in the sense of independent of the zero-Frankel axiom, he's laying the groundwork for the next mathematician. This is the best I can do today. And I leave it to my students or the next generation after that, because I've given you that groundwork to show you why it's not provable. And it's a very long, but very elegant proof. That's very, very different than undecidable. Because if you just said, oh, well, this is undecidable, that wouldn't even be a proof in a mathematical sense, right? You've got to show what you've got to do the work and say, this is the problem. And I'm going to prove to you that the continuum hypothesis cannot be provable within the traditional axioms of set theory. Now, Cantor said, I'm a Platonist, I accept that it's not now provable within these axioms, but I'm going to assume it to be true and see what other kind of work it can do. And he did assume it to be true, and it has shown itself to do certain work in other kinds of set theory axioms, which means that the set theorists are continuing to work on this problem, and will continue to work on this problem. Now, but that's not Badiou's notion of Platonism. He doesn't like this. He says, we call Platonic the recognition of mathematics as a form of thinking that's intransitive to perceptual and linguistic experience, and which depends on a decision that makes room for the undecidable and assumes that everything which is consistent exists. Now, the two statements actually seem to completely contradict each other, at least as I read them, so I'm going to focus on the decision that makes room for the undecidable. In other words, he reads Cantor, right, as reaching this very great mathematician who worked with such care, as reaching the point where Paul Cullen shows that the axioms of Frankel set theory cannot be used to prove this continuum hypothesis, and therefore he said, just fuck you, and I'm going to decide to assume that it's true anyway. That's not what he did. He said, well,